I am Chinghong Max.
I am Choi Ji-Kun Max.
Student from Department of Electronic Engineering, City University of Hong Kong. The topic is mobile device and cloud server-based intelligent health monitoring systems. This is my objective of my project, to develop a wireless motion sensor for automatically monitoring and alerting signs of a fall from elderly individual. Here is the functionality of the device when the project is completed. First, provide automatic monitoring of motions and spot changes. For example, in nighttime, a accelerometer will detect the restlessness of users when they are sleeping. In daytime, they will monitor their motion activities and alert them when they are required to have more workout. Second, when it detects falling down of a user, it will send distress signal to the correspondent. Third, when motion data is connected, it will be saved to SD card when Bluetooth connectivity is unavailable for offline analysis. When Bluetooth connectivity is available, it will in turn send the data collected to cloud server for real-time analysis. The project is divided into 3 parts. Part 1 is motion sensor hardware design. Part 2 is motion sensor software design. Part 3 is motion pattern recognition.
Let's talk about the motion sensor hardware design. The motion sensor hardware design based on the MM8451 accelerometer, and 2 modules has been built. One is focused on the Bluetooth and SD card storage, and the other one is focused on the Wi-Fi and cloud computing capability.
In case you wonder what accelerometer is, let me introduce it to you. Accelerometer is a device that measures acceleration it perceives from time to time. Output is in the form of x-axis, y-axis, and z-axis. It has many applications in daily life. For example, from Wii Remote to iPhone game controller. This picture perfectly describes the way the device perceives acceleration in x-axis, y-axis, and z-axis.
The prototype of motion sensor with Wi-Fi is completed. Now we are working on minimizing the board size and minimizing the power consuming. After that, we will improve the user interface. The motion sensor with Wi-Fi able to send the real-time accelerometer data to cloud database through Wi-Fi ports. After that, the analysis will be done by the database separately. This is the user interface for recording the accelerometer data, and the output file is CSV file, which can open with Excel.
Currently, the prototype is completed, and only minimization of board size is required. 2 modes are available on prototype. One is SD card mode and the other one is USB mode. SD card allows saving of motion data and analyze later. USB mode, or say Bluetooth in the latest version, allows real-time graph plotting by the computer. Here is the hardware layout of our prototype, which is based on microchip development kit. As you can see, there's a Wi-Fi module there. However, we are not going to introduce it to you because we have found that the power consumption is pretty great, and then we have replaced the Wi-Fi module with Bluetooth. Here is my first attempt of minimizing the above circuit. Bluetooth and buzzer has been added. The function of the buzzer is for alarm when fever is detected. Here is my second attempt of minimizing the above circuits, with the integration of the whole circuits into a single one and removed the USB port. When SD card is being used, it can only store raw data of time and accelerometer's output. Since output in millisecond is not available by microchip, I assigned an estimated millisecond time slot for all data regenerated within the same hour, minute, and second once the program processed the data. It can also allow selection of data from a whole bunch of data and deletion of some data. Here is the motion data output after modification. When USB mode is being used, the data receiver allows saving of motion data into a text document just like the SD card did, and also plot the output in real time. Same as the SD card mode, 2 modes of output are available. One is in millisecond and the other one is in clock mode. Now we will discuss about the softwares. I created plotting function of output data using MATLAB. In theory, when integrate acceleration gives velocity, Increased velocity gives displacement, therefore position tracking is possible. However, error through double integration is so large that the method is not accurate, as shown in the graph below. As not all machines are installed with MATLAB, for that, I created a program written by C# and added some functionalities. This is the layout of my program. X, Y, and Z axes could be turned on or off. Moving average filter could be added to make some motion pattern more visible. Currently, motion pattern recognition is still under development. Aim is to identify different motion patterns by using computer software, mobile application, or even the chip itself. Here is the graph of free-fall. At the free-falling instant close to 2.6 seconds, there is a sharp peak. Then, the reading returns to background level. Rotational freefall is different from the previous one, as it involves with the interchange of axes. Now, not only Z-axis detects the sharp peak, but also the X-axis and Y-axis. For jumping, motion pattern is similar to the freefall one. However, there is a small peak before the sharp peak, indicates that the nearing down action. Walking produces regular peaks in X-axis and Z-axis. The effect on Y-axis is small. Running produces patterns similar to walking, but intervals are more intense. In walking upstairs, sharp peaks could be found on Z-axis, and is not as uniform as general walking and more intense than that. In walking downstairs, pattern is similar to walking upstairs, but peaks at Z-axis are of greater magnitude. Although some might think that accelerometer is small and insignificant device, it depends the way you see it and use it. It can be used to monitor elderly's movement, to send distress signal when accident occur like fall onto the ground. It can also be used as pedometer to count steps, alert user when device indicate that they need to work on more. It can identify different motion patterns and create health reports about their exercise intensity every day. The best application and possibly the hardest one to achieve is position tracking for underground workers or blind people whenever positioning by Wi-Fi or GPS is not available. Then, they can always know where they are. Here comes the demonstrations. The prototype is connected to my computer via USB port. Now we configure it and then start the assembling. The program can show real-time sensor output in the test port and graphical port. When the test document is generated, we can plot it using the software I wrote. As previously mentioned, you can turn on off the axis or even add in a moving average filter. Apart from the functionalities I mentioned, the device can also detect freefall by itself by alarming the buzzer. This is the example. Now I will demonstrate the SD card function. When USB is connected, it will present as a removable media in system. When I press the button, the device will be detached and start disassembling. When button is released, it will be removable media again and can view the contents. I will make use of another program to modify the raw data.
This is the demonstration of motion sensor with Wi-Fi. After collecting to the data and press the start button, the user can start to record the data. After record the data, you can add the data to a CSV file.
That's the end of the presentation. Thank you.